Hello. Hello, everyone. Let's start this session on topic of smart grid basics to advanced technology. Actually, this is the last session for this course, which is run for 12 weeks. And in these 12 weeks, we have talked about various things regarding the smart grid, and we have solved numerous types of questions. So in this lecture, I am going to do here, uh, I will conclude whole lecture, and we will solve more questions. So before I start, I would like to introduce myself. I, Mohammad Owais Khan, the Prime Minister Research Fellow, Department of Electrical Engineering, is taking this course as a teaching assistant for Smart Grid Basics to Advanced Technologies. So basically, what we have studied for the 12 weeks is what is a smart grid, okay? What is its need? Why we have to introduce a new technology uh, nowadays? Why we have to introduce new technology like a smart grid? What is its need for it? Okay, and how it helps, it improves the conventional grids. Okay, this we have studied in journal. Okay, and also we what we have studied. Also, I hope I am audible, Sanchit. If not, you can write in the message here. Okay, so what we have studied here is that why we need a smart grid, what is advantages other over the conventional grid. Okay, and then we have talked about the microgrids. What is a microgrid? It is actually a small part of a smart grid, and how it behaves, how we can connect it to the grid or any other you know sources. So basically, they operate in two modes. One is islanding mode, where islanding is done. The microgrid is disconnected from the main grid. Either it is intentional or non-intentional. But another mode of operation of the microgrid is grid connected. Okay, we have studied about it also, how the grid is connected to the microgrid, what are their advantages. So basically, what microgrid is comprised of different types of sources like distributed. Okay, distributed energy sources here. Okay, and these distributed energy sources in microgrid generally are the renewable based energy sources, which are solar or wind. Okay, another component of the microgrid is the loads of a small area, small geographical area. Okay, so a microgrid comprises, and it may or may not be connected to a grid, may or may not be connected to a grid. Maybe it is an isolated, or it is a grid connected. Okay, so we have studied about this. Then we have also studied. Okay, then we have also studied the various architecture of a microgrid, which is DC and AC, in which in the DC microgrid, what we have studied that we have connected solar, wind, all these distributed energy resources to the DC bus. Actually, here we use various types of power electronics converter. As we know, wind generally generate the power in a AC form, so we have to use an inverters like this. Here we have used bidirectional, unidirectional converters, where we can control the voltage of the solar. So these all be various types we have generally studied in this. Then we have studied AC microgrid, where the bus is AC and it is directly connected to the grid. It is also directly connected to the wind, and it is connected through a power electronics converters through solar. Okay, and it is also connected to the AC loads. Then we have studied a DC-AC microgrid system, where we have connected the DC loads or buses to the DC buses, and actually the solar-based energy sources are connected to this. Then there is another bus, which is an AC bus, which is connected to the grid, and and the AC loads are connected here, because in general there are mostly AC loads we have, but there are some DC load also. Then there is connected, these two buses are connected through an ILC, which is interlinking converters. Based on that, it will determine how the power is going to transfer from AC to DC. If the source is connected on the DC bus has a higher generation and the requirement is higher on the AC side, then through these interlinking park converters, the power will flow from AC and DC to AC and vice versa also. So these all we have studied in detail, in detail form. So basically, we come to the question: what is a smart grid? So what is a smart grid? It is actually a two-way communication. It is a two-way communication, because in general, our conventional generation or system is conventional system is one way. Okay, and the conventional system of generation, or I would say, or distributed generation, is also distribution system is also passive. What do you mean by passive? It means, like, we calculate the demand over a region, and we estimate that for this region, let's say y megawatt amount of energy will be required. So we will design a generation for this region. But what happens in the active distribution network, due to the integration of DARs like solar, wind? So they are also generating energy in this region. So the demand will reduce from the convention. So based on that, it is based on that, what will happen here is that we have to again forecast, or we have to plan for that region also. So based on that, these type of distribution system which have solar or DER, basically distributed energy sources, are integrated in the region, in the distribution network. Those are known as active distribution network, which means they can generate power on their own also. Okay, so this is like this. Now comes to what is a smart grid. Actually, what happens here is that because there is so much distance between the generation and the load centers, I would say. See, generation is happening over there and the load centers are there. So basically, there are various, problems arising, like of reliability of the transmission line, okay, also stability, and also the economic issues. Like it is very costlier to transmit energy from the power from one point to another over a large line. So basically, but in previous time we have this only option, like we have to use this. But nowadays, due to the integration, due to the advancement of the smart grid, what we have here is that we can you know satisfy the demand to this load center locally also, okay, by using various DERs like solar, wind, biogas, fuel cells, ultra capacitors, or SME, semiconductor capacitor. These all can deliver the energy to these load center, and they are locally installed, means they are very close to the load centers. Okay, so what happen here is that it will reduce the line losses. Line losses will be reduced. Okay, uh, just a second. Just okay. So it will reduce the line losses because the length of the transmission line is reduced because they are generally locally installed. But what happen here is that they will increase the, I would say, the stability issues, because when they will integrate into the system, there may be voltage stability and the frequency stability. We have already talked it about in our lectures previously, how we can tackle these. So stability is still the main issue. So that's why a smart grid system, what it will do, it will intelligently allocate these distributed energy sources to the distribution network, and also helps in improving the, what we can say here, protection scheme. Also it will help in improvement all in the stability and the reliability. Okay, it will happen, it will or it will what it will do, the smart grid will digitalized. It is a digitalization of all these things. So basically, in previous time, whenever there is a fault occur, a human resource goes and analyzes that and solve it out. But in a smart grid, this work will be done by sensors, actuators. Okay, so it will be a fast restoration of the services. And what happened here is that because whenever there is any event occur, it will record some data. Why this event occur, how it, how, what are the possible reasons for that. Based on that data, we can analyze that data and 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 also uses various intelligent techniques so that so that those type of outages or I would say the service disruption will not occur in the future. So basically, it will help in the we can say here this integration of intelligent methods, or I would say techniques, will help in the रिडक्शन ऑफ आउटेजेस। इससे क्या होता है, जो भी हमारी आउटेजेस हो रही होती हैं इन पास जो हो चुकी होती हैं, उससे हम एक डेटा जनरेट करते हैं कि ये आउटेज क्यों हुई है, व्हाट इज द प्रोबेबल कॉज फॉर दिस एंड हाउ वी कैन यू नो प्रिवेंट दिस इन द फ्यूचर। सो और इसकी मदद से हमारा जो है सिस्टम विल बिकम मोर रिलायबल। Now, another important advantage of the smart grid it is that due to the rapid growth in population, there is a high energy demand. Also, one of the main reason of the high energy demand is that we are going towards a digitalized world. Everyone has, you know, the electronic appliances have been increased drastically in the last 10 to 15 years. So basically, if the electronic appliances increase, the energy demand will surely will increase. So based on that, there is a high energy demand. So there are two options. Either we supply this from the conventional generations like fossil fuel based, which we do, or either we use DERs. So basically, if we don't have any smart grid, like two-way communication channel is not there, then we would have supplied with a fossil fuel base. But the problem with the fossil fuel based generation is that it generate lot of emissions, you know, carbon emissions. And there is temperature of the earth is also going to increase and due to these emissions, and it will increase the phenomena of global warming. Okay, so I would say this is not a you know an intelligent choice to satisfy the demand from the fossil fuel generation. Also, one of the major aspects of this are fossil fuel cannot be replenished. Like it for it when it is one time. Like if we use it for the generation of electricity, it cannot be replenished further if they are diminished. So basically, in recent times, their reserves also getting reduced. So basically, what will happen here in the coming times, these fossil fuel will not be able to generate the demand of the power which can be met by the which should be which is generally needed. So basically, one another intelligent thing is to integrate DER, and this integration of DER basically, more importantly, two types of energy are there: solar, wind. Predominantly, if we analyze the Indian geographical location, these two are highly highly selected for the energy generations, in which solar is a higher. uh, percentage. So basically, the benefit of this is that it will not generate as much carbon emissions as fossil fuel. See, every type of generation, either indirectly or directly, they will generate carbon emission. But the question here is that which is the lesser of the evil. So basically, what we are selecting is that which fuel will generate lesser amount of the carbon emission. So basically, a solar is a much more intelligent choice for that, solar and wind. But another thing here is that in order to integrate any distributed energy resources, if they are integrated to any grid, there are various challenges like voltage stability. We are creating new challenges for us like frequency stability or various type. So we have talked about how we can reduce the frequency and voltage stability. So that's why a smart grid system help in the integration of DAR to the our electrical distribution networks, and it will also help in the efficient. Okay, one of the major another uh, another advantage of, I would say, of DAR is that they are locally placed, means they are placed near the load center. So we don't have to laid out very long transmission line for them. It can be placed near the load center and the energy can be transferred, so it will help in the lesser power, or I would say line losses. Okay, so another thing is that here, see, what happened here is that in the electricity markets, which is we generally known as power market. So basically, generation of electricity from a solar is much lesser than the generating electricity from fossil fuel. तो इससे क्या होगा, जो जनरेशन ऑपरेटर्स होते हैं और जो ट्रांसमिशन ऑपरेटर्स होते हैं, तो उनके लिए इलेक्ट्रिसिटी जनरेट करना फ्रॉम अ सोलर इज मच लेसर. तो उसकी वजह से क्या होगा, दे कैन गिव इंसेंटिव्स टू द यूजर्स. ओके, so it will help in the reduction of the electricity prices also. इसी वजह से जनरली नाउडेज गवर्नमेंट ऑफ इंडिया ने देयर इज अ टाइम ऑफ यूसेज पॉलिसी इंट्रोड्यूस करी है, which means during the solar hours during the solar hours the electricity will be lesser, means the prices of this electricity will be lesser than the non solar hour. तो इससे क्या होगा कि जो ज़्यादा से ज़्यादा डिमांड जो है वो शिफ्ट हो जाएगी सोलर आवर्स में. फिर उससे क्या होगा, इट विल लीड टू द हायर integration of solar energy. Okay, plants, I would say, like this. तो अब क्या है कि जो स्मार्ट ग्रिड है उसके there are different parameters to it. One is smart infrastructure, another is smart communication, because communication is very much important for the smart grid. Okay, generally use TCP by IP protocols. Okay, then smart energy management. स्मार्ट एनर्जी मैनेजमेंट से क्या होगा, एक ऑपरेटर रहेगा. I will explain it later on, right? First I will write down here. Then the smart protection. Smart protection से मतलब क्या है, it is a digitalized protection, like whenever there is any outage or any relay, coordination breakdown, like anything that happen. So all digitalized action will be done. Now comes to the another thing, which is smart energy management. तो क्या होता है स्मार्ट एनर्जी मैनेजमेंट में? एक कंट्रोल ऑपरेशन सेंटर होता है, जिसको हम कहते हैं लोड डिस्पैच सेंटर। ठीक है, इसके पास हर चीज की इंफॉर्मेशन होती है। इट हैज द इंफॉर्मेशन ऑफ ट्रांसमिशन, ओके, it has the information of generation, it has the information of customers, and it has the information of the electricity price market. It also has the information of the DER generation, कितना जनरेशन होगा। बेस्ड ऑन दैट ये क्या करेगा, इट विल फ्लैक्ट कि किस एरिया में कितनी एनर्जी जानी चाहिए। ठीक है, ओके। सो देयर आर वेरियस लोड डिस्पैच सेंटर इन आवर कंट्री। तो ये क्या करता है, इसको पता है कि ट्रांसमिशन कितना हो रहा है, जनरेशन कितना हो रहा है, किस कस्टमर्स को की रिक्वायरमेंट क्या है, वेदर दे आर एसेंशियल और नॉन एसेंशियल। और इसको इट आल्सो हैज knowledge of the electricity price market, कि is what is the rate going on, and it also has the information of the generation of the DEA. Based on that it will take actions, okay. So स्मार्ट ग्रिड के अंदर लोड डिस्पैच सेंटर्स हैव अ वेरी prominent role, okay. And then we have, hmm, okay. So basically this is all about. So आज क्या है, बिकॉज वी डोंट हैव एनी आई वुड से कि मेरे पास कोई वो नहीं है कि क्या पढ़ाना है, क्योंकि ऑलरेडी द सिलेबस हैज़ बीन completed. So I am just giving you an overview of that, कि क्या क्या हमने पढ़ रखा है. Then we have also talked about various types of सोलर DER जनरेशन, ये भी हमने पढ़ा था इसके अंदर, जिसमें फर्स्ट है सोलर। सोलर क्या है, इट इज़ वेरी इकोनॉमी friendly, also environmentally friendly, but it has a slight disadvantage. It is highly dependent on the weather, highly dependent on weather, okay. So basically what is here is this, just a second. ठीक है, so the thing is here, it is highly dependent on weather. So ये क्या रहता है कि if the sun light is abundant, then it will produce the energy, okay. But basically तो क्या होता है, इसकी इंटरमिटेंसी, जो इसकी एनर्जी जनरेशन है, वो किस पे डिपेंडेंट है? आई विल सॉल्व, आज मैं ज़्यादा क्वेश्चन सॉल्व कराऊंगा फ्रॉम बेसिक्स टू दैट, ओके। तो इसमें क्या है कि इसकी जो एनर्जी जनरेशन है इट इज जनरली डिपेंडेंट ऑन सनलाइट। एक तो सनलाइट पे रहती है, दूसरी है टेम्परेचर। ठीक है, अगर बहुत हाई टेम्परेचर हो जाएगा जनरेशन विल फॉल डाउन। ये हमने देखा था एमपीपीटी वाले लेक्चर में, कि हमने देखा था कि किस तरीके से जनरेशन फॉल डाउन कर जाती है, और अगर बहुत लोअर टेम्परेचर होगा देन ऑल्सो जनरेशन ऑल्सो फॉल्स डाउन। तो ये इसको हम कहेंगे इट हैज़ अ इंटरमिटेंट नेचर। तो इसीलिए इंटरमिटेंट नेचर को एड्रेस करने के लिए वी हैव इंट्रोड्यूस अ बैटरी स्टोरेज सिस्टम, बैटरी स्टोरेज सिस्टम, और भी आई वुड से एनर्जी स्टोरेज सिस्टम। तो इसमें क्या होता है, क्योंकि क्या होगा कि सम टाइम देयर इज अ नीड फॉर द एनर्जी बट सोलर विल नॉट बी प्रोवाइडिंग at that time. The temperature is not good, or I would say the sunlight is not as much sufficient for the energy production. So what will happen here is this: whenever whenever there is excess of solar energy available, that energy can be stored in the battery. Okay, so can be stored in the battery. So it will help in effective utilization of resources. तो इससे क्या होगा, जब हमें ज़्यादा ज़रूरत होगी, ओके, एनर्जी की, और उस टाइम अगर हमारे पास सोलर नहीं है अवेलेबल, फ्रॉम दैट सोलर द एनर्जी इज नॉट अवेलेबल, वी कैन यूज द यू नो व्हाट एनर्जी फ्रॉम द बैटरी. ओके, so I would think it's better to solve some questions. Okay, the number of questions will be much higher today, and it will give you a better understanding. पढ़ तो आप लोग चुके ही हैं, ठीक है. So I will start from some basic questions, then we will move on toward the some other questions. So whenever I will write a question, you should write in the chat box what is the answer to this. Okay, so okay, so I will start from the basics first, then we will move on. Just a second. Question number one: what is a smart grid? A. Grid operates with DER. B. Traditional grid with automation, without automation. C. grid with enhanced communication, monitoring, and automation features. ठीक? D. Both B and C. तो मुझे बताइए क्या रहेगा इसका. I think people who have joined are not listening or not. See, today there is nothing to teach you about because already I have talked about this every topic in detail. So basically, today what I am going to do here, I have just given a recap of the subject. Then we will solve the question. So I would say write any answer. It doesn't matter whether you are right or wrong, but participate in that. Okay, it will help you in your examination or altogether, or in general knowledge, or the better understanding. So whoever are present should write the answer. So क्या है? What is an smart grid? Okay, a grid operates with DAR. ये भी ठीक है. It is also correct. Traditional grid without automation. नहीं. Automation is there. It is wrong. So a grid with enhanced communication and monitoring and automation feature. It is much better, it's the definition of a smart grid in comparison to A. So we can say it is also wrong for this question. So C is the correct answer. Okay. Question number 2. What is the benefit of a smart grid? Increased energy consumption, decreased need for automation, better control over grid operation, D. Reduced dependency on renewable energy sources. So give me the answer of 2. Yes. So the correct answer here is the first option says increased energy consumption. No, this is not a decreased need of operation is wrong. Better control over a grid operation. So C is the correct answer. Question number 3. What is interoperability in smart grid? A. technique which transmission losses be ensure compatibility and seamless communication between various devices. C. Ability of grid to operate independently. D. None of the above. Yes. तो क्या है इंटरऑपरेबिलिटी क्या है इट इज ये क्या करता है कि सीमलेस कम्युनिकेशन बिटवीन वेरियस डिवाइसेस को इंश्योर करता है क्योंकि स्मार्ट ग्रिड में कम्युनिकेशन इज वन ऑफ द मोस्ट इम्पॉर्टेंट थिंग क्योंकि लाइक फॉर एग्जांपल क्या होता है जो स्मार्ट मीटर्स होते हैं ठीक है तो क्या होता है स्मार्ट मीटर्स में क्या होता है कि आज generally most of the meters right now in India they are not smart but there are some percentage of the meters which are smart. स्मार्ट मीटर में क्या होता है कि जनरली गवर्नमेंट इज एनकरेजिंग टुवर्ड्स स्मार्ट मीटर व्हाई इससे क्या होगा कि लेट्स से आपके घर पे सोलर पावर प्लांट है लेट्स से इट इज बेस्ड ऑन सोलर ओके और यू हैव आल्सो अ कन्वेंशनल जनरेशन लाइन जिसको हम कहते हैं लाइन है आपके पास ठीक है अब डिपेंड क्या होगा वो लाइन एक्चुअली क्या होगा जस्ट अ सेकेंड इट विल कमिंग फ्रॉम हेयर ओके सो ये जो है क्या करेगा डीईआर सो डीईआर क्या ये स्मार्ट मीटर क्या करेगा लेट्स से कि आपके पास एक्सिस सोलर पावर है तो स्मार्ट मीटर व्हाट विल इन अ स्मार्ट ग्रिड व्हाट विल हैपन दिस एक्सिस सोलर पावर you can sell to a grid okay by some time of usage amount okay डिपेंडिंग किस टाइम पर आप बेच रहे हो ठीक है तो ये आप एक्सेस सोलर हम ग्रिड को वापस भेज सकते हैं ठीक है तो अब इसके बीच में कम्युनिकेशन हो रहा है कि अगर तुमने बोला कि यस आई वांट टू सेल द दिस मच अमाउंट ऑफ एनर्जी टुवर्ड द ग्रिड तो ये कम्युनिकेशन पैटर्न एक पहले एनर्जी थोड़ी ना जाएगी फर्स्ट द कम्युनिकेशन will be established based on that communication the command over अब let's say क्या होता है generally you have all this interface on your mobile तो आप देखते रहते हो कि ठीक है मेरे पास इस टाइम पे एक्सेस सोलर है आई वुड sell it to the grid so basically what will happen you press some things over in the mobile then it will send a signal and after to the smart meter it will allow this much amount of energy so it is all based on the communication so communication is very much important in the smart grid okay so question number 4 how do smart grid reduces emissions a by reducing energy demand by reducing fossil fuel plant. Okay. C. By integrating the number of consumers. D. None of the above. Sorry, just a second. Just what I'm writing. Oh, by integrating the DER, renewable based. Okay.
C.
Yes. You can write in a chat box. Okay. It will be much better. So C. Yes. C is the correct. Okay. So now let's move to another other questions which I have framed for you. Okay. Question number 5. Okay. Just a second. Hmm. Which of the following is correct about smart grid? Okay. So first is better integration of DAR. B. Supplying the power demand through renewable energy sources only. C. Better communication standard. D. Both A and B. E. Both B and C. ठीक है चलो इसके बाद क्या हुआ, कहाँ गए? Write in the chat box the answer. Which of the following is correct about smart grid? So basically, better integration and better communication standards. So D is the correct answer. Better integration of D है. It is not wrong. It is not correct. तो स्मार्ट ग्रिड में दोनों का इस्तेमाल होता है, एनर्जी सोर्सेज फ्रॉम द रिन्यूएबल और fossil fuel. Our aim is to reduce the fossil fuel based fuels, but not completely. We cannot remove that. So now another question, which is six. The GPS satellite arranged in orbital planes displaced by each other. Actually, displace each other by first 60 degree, B 30 degree, C 45 degree, and D 90 degree. Answer लिखो chat box में. Whether it is wrong or right, it doesn't matter, but you should participate in it. Okay, try to give correct answer, but still, so that I can, you know, see. See 30 degree. Okay, so what happened here is GPS satellites are arranged in orbital plane displaced by each other at a 60 degree. ये मैंने क्वेश्चन कराया था इन द थर्ड आई थिंक फोर्थ लेक्चर एक्चुअली. सो द करेक्ट आंसर हियर इज 60 डिग्री. ओके, और ये जो अरेंज करी जाती हैं, दे आर अरेंज इन अ 6 ऑर्बिटल प्लेन्स. ओके, और डिस्प्लेस बाय 60 डिग्री फ्रॉम ईच. और इनका जो इंक्लिनेशन होता है फ्रॉम इक्वेटोरियल प्लेन, इट इज अराउंड 55 डिग्री इंक्लिनेशन फ्रॉम इक्वेटोरियल प्लेन. ठीक है, सो यू शुड रिमेंबर दैट. क्वेश्चन नंबर 7. द वर्ड of a file standard of synchrophaser standard defines the total record. Okay, defines the size of total record. Okay, तो इसके ऑप्शंस हैं, फर्स्ट बी है, थर्ड सी है, सेकंड एंड डी है, फोर्थ एंड फिफ्थ. सो गिव मी द आंसर. सी. Anyone other than that? So क्या है? Yes. So the file standard, सेकेंड फाइल स्टैंडर्ड जो है वो क्या बताता है? इट डिफाइंस द साइज ऑफ द टोटल रिकॉर्ड. जो भी क्या होता है, जो इस सिंक्रो फेजर का डेटा होता है, इट कम्स इन अ फैशन लाइक दिस। उसमें कुछ एक फॉर्मेट होता है, इट कम्स इन अ फॉर्मेट। ओके, वो फॉर्मेट क्या होता है कि फर्स्ट वर्ड, फर्स्ट वर्ड ऑफ टू बाइट क्या बताएगा, टेल्स यू, टेल्स अबाउट द सिंक्रोनाइजेशन ऑफ डेटा ट्रांसफर। ठीक है, ये बहुत इंपॉर्टेंट है, इसको ध्यान रखना। देन सेकंड वर्ड उसका क्या बताएगा, सेकंड वर्ड क्या बताता है, इट डिफाइंस द साइज ऑफ टोटल रिकॉर्ड, कि पूरा जो आया है डेटा उसका साइज क्या। ठीक है, और जो थर्ड वर्ड डिफाइंस द ओरिजिनेटर ऑफ डेटा। ठीक, फिर उसके बाद क्या होते हैं, दो वर्ड्स प्रोवाइड, नेक्स्ट टू वर्ड क्या प्रोवाइड करते हैं, अदर देन दिस, these words, next two word provide second of the century, second of the century and fraction of a second, at which data is reported। ठीक है, is being reported, ये बताता है। इसको हम SOC कहते हैं और FRASEC कहते हैं। ठीक, ये दो चीजें बता। फिर इसके बाद आता है लास्ट वर्ड of the synchrophasor standard, last word of synchrophasor standard tells you about the checksum to determine any error in the data transmission। ठीक है, तो इसमें इस तरीके का ये स्टैंडर्ड है। फर्स्ट स्टैंडर्ड में क्या है, पहले स्टैंडर्ड में क्या है, जो फर्स्ट वर्ड ऑफ द स्टैंडर्ड क्या बताता है, फर्स्ट वर्ड ऑफ स्टैंडर्ड बताता है सिंक्रोनाइजेशन ऑफ डेटा ट्रांसफर के बारे में। देन सेकंड वर्ड बताता है साइज ऑफ टोटल रिकॉर्ड जो भी है। थर्ड वर्ड डिफाइंस द ओरिजिनेटर, कि कहाँ से ओरिजिनेट हुआ है, इट डिफाइंस यूनिकली। ठीक है, हर तरीके के ओरिजिनेटर को अलग तरीके से करस्पॉन्ड करता है। इसके बाद दो वर्ड्स आते हैं, वो बचाते हैं सेकेंड ऑफ द सेंचुरी और द फ्रैक्शन ऑफ सेकेंड, किस रेट पे डेटा को रिपोर्ट किया गया है। And then the last word tells you about the checksum to determine the error in any data transmission. Okay, so this is all about this question. So question number 8. Okay. Hmm. एक क्वेश्चन है, डिजिटल fault recorder determines which type of fault? ए फॉल्ट का क्या टाइप? एक्चुअली डिटरमाइंस, जस्ट अ सेकंड, ठीक है। बी faulted face, C fault location, D all of these। तो बताओ क्या आंसर है इसका? ये डी। अच्छा जी, anyone other than him? Okay, the answer is correct, is all of these। तो एक्चुअली क्या है, DFA क्या करता है? DFR, आई वुड से DFR, डिजिटल फॉल्ट रिकॉर्डर, क्या करता है? इट परफॉर्म सिग्नल प्रोसेसिंग टू आइडेंटिफाई एनी प्री और पोस्ट फॉल्ट, ठीक। इट ऑल्सो चेक्स द स्टेटस ऑफ डिजिटल चैनल्स, स्टेटस ऑफ डिजिटल चैनल्स, ठीक है। This DFR also determines fault type, fault type, fault location, fault location, and what it also, and faulted phases, ठीक। ये सब चीजें ये करता है। So the next question here is question 9, ठीक है। So the question 9 here is which one? The lower and upper limit for TDS are said to be respectively, ठीक। टाइम डिवीजन सेटिंग्स, प्रोटेक्शन का सवाल है। 0.051 बी, 0.05 एंड 1, सॉरी, ओके, 0.005 एंड 1, सी 0.5 एंड 1.05, डी बोथ ए एंड बी। तो आपको ये बतानी है टीडीएस का अपर एंड लोअर लिमिट क्या सेट करी जाती है. I would say you write in the chat box what it is. D. Okay. Yes. तो क्या है इसका, मैंने पढ़ाया था आई थिंक in some lectures. I have solved this question, so I just repeat that question to check whether you have remembered or not. So basically इसकी जो लोअर लिमिट होती है it is 0.05 and upper limit होती है 1. So the answer is no. You don't. No, no. This is the correct answer, I think. Yes. ठीक है. So now another question. Question number 10. What are the key deciding features of battery storage system? A. Charging and discharging time. Okay. B. Minimum number of storage cycle. C. Minimum storage period. D. All of these. यस, आई नो ये वाला आंसर सही दिया जाएगा. सिंपल है क्योंकि डिसाइडिंग फैक्टर्स क्या होते हैं बैटरी स्टोरेज सिस्टम्स के, कि चार्जिंग और डिस्चार्जिंग टाइम कैसा है. ठीक है, इट इज ऑल्सो वन ऑफ द फैक्टर. स्टोरेज साइकिल्स यू नो also helps in determination of this. So all these, so answer all of these is the correct answer. Question number 11. Variable speed drives loads are type of load. First है constant voltage. C. Constant impedance. C. Zip load. D. Constant power. So variable speed drive loads are which type of load? So write in the chat box. 10D. अच्छा, okay. 10D. Okay, okay, okay. 11. 11. The question number is 11. This question number is 11, not 10. 11A. अच्छा, okay. Anyone else? Try to give an answer. Correct or not, don't worry about it. D. No, variable speed drive loads are constant power. ठीक है? So D is the correct answer. Question number 12. Energy storage level of a supercapacitor is determined or is represented by represented by a terminal voltage, B charging current, C volt ampere, D none. Question number 12. Hmm. Okay. क्या energy level of a supercapacitor is represented by no, it is represented by terminal voltage. ये तो क्वेश्चन मैंने सॉल्व कराया था सुपर बैटरी स्टोरेज. ठीक है ना. सो नेक्स्ट क्वेश्चन. जस्ट अ सेकेंड. जस्ट अ सेकेंड आई विल. ओके. So question number, what it is? 12. This is question number 30. Evaluate the following statement regarding ramp rate in power system. Okay. Gradual change in generation levels over a specific time period. Okay. B. Ramping is more pronounced in power system which is heavily rely on stable and consistent एनर्जी सोर्स, ठीक। सी, हैव अ impact on stability, reliability of power system. D, both A and B. E, both A and C. So take your time, r- read it and give me the answer. बाकी लोग आंसर बताएं क्या हो सकता है। ओ, बस एक ही बताया है, एक ही ने। बाकी लोग also try it. It doesn't matter whether it is right or wrong. You should, you know, give it a go. देखो क्या है, रैंपिंग क्या बताता है, क्या करता है, इट टेल्स यू अबाउट द ग्रेजुअल चेंज इन जनरेशन लेवल ओवर अ स्पेसिफिक टाइम पीरियड, कि जनरेशन लेवल्स कैसे इंक्रीज करे जा रहे हैं रैंपिंग रेट से। हर जनरेटर का अलग रैंपिंग रेट होता है, ठीक है। तो ये तो सही बात है, ठीक है। रैंपिंग इज मोर प्रोनाउंस इन अ पावर सिस्टम व्हिच इज हेवीली रिलायंट, नो नो, इट इज नो, इट डज नॉट मेक्स एनी सेंस। हैव अ इम्पैक्ट ऑन द स्टेबिलिटी एंड रिलायबिलिटी, यस। अगर किसी भी सिस्टम का रैंप रेट इंक्रीज कर देते हैं, अब generators are not capable to deliver at that ramp rate, so it will have a effect on the stability and the reliability. C is also, so I think E is the correct answer. Okay, so let's solve another question. Question number 14. Pumped hydro power stations are looked as: first, voltage regulators for the grid. Okay. B, conventional generating sources. C, frequency regulators for the grid. D, both A and B. C. Okay. बस एक ही ने, और बाकी लोग क्या कर रहे हैं? They should also try to give the answer. देखो क्या है, सी डी डी, ओके। देखो इसमें है कि pumped hydro powers is generally looked at a frequency regulator। ठीक है, जनरेशन ज़्यादा होगा, लोड कम होगा, ओवर फ्रीक्वेंसी होगी, तो वहाँ पे उसको रेगुलेट करेगा। इट विल वर्क एज अ फ्रीक्वेंसी रेगुलेटर फॉर द ग्रिड। क्वेश्चन नंबर आई थिंक 15। ओके, ड्यू टू, ओके, जस्ट इन विच, in which mode of operation fault current in microgrid is high। okay, ठीक। फर्स्ट, grid connected mode, B, islanding mode, C, same for both A and B, D, both A and B, same fault current for both A and B। तो बताओ, क्वेश्चन नंबर 15 का आंसर बताया जाए। बाकी लोग they also tried। बस एक ही आदमी जवाब दे रहा है, और there are so many people, why are not they answering? ओके, क्या होता है कि let's say this is grid, okay, this is connected to this is DE। let's say there is a fault occur over here, okay, fault। अब फॉल्ट क्या होगा, दो करंट फ्लो करेंगे, एक करेगा फॉल्ट करंट जिसको IF DER, और एक फ्लो करेगा IF ग्रिड। ठीक है, और अगर ये इस तरीके से, अगर आइलैंडेड मोड है, तो इस टाइम फॉल्ट करंट किसकी वजह से रहेगा, इन आइलैंडेड में ओनली ड्यू टू DER। बट इफ इट इज कनेक्टेड इन द ग्रिड कनेक्टेड मोड, DER प्लस ग्रिड दोनों की वजह से, तो करंट इसमें सबसे ज्यादा कहाँ रहेगा, इन अ ग्रिड कनेक्टेड मोड। क्वेश्चन नंबर 16, a relay plug setting can be altered by changing first air gap, B, backup stop, C, number of ampere turns, and D, all of the above। Okay, give me the answer। 16D. Yes, yes. ओके, देखो, जो प्लग सेटिंग का क्या होता है, इट रिलेज आर कनेक्टेड टू सीटीज, तो उसमें अगर हम एम्पियर टर्न्स चेंज कर देंगे, वी कैन चेंज द प्लग सेटिंग, so that's why C is the correct answer, not D. Okay, question number 17. Okay, just let me get some questions for you. Oh, I think you are understanding well. Okay, okay. What is meant by Y percentage droop in local hierarchical hierarchical कंट्रोल? ठीक, पहला है स्टेटमेंट, a y% deviation in nominal frequency causes 100% change in output. ठीक, b a y% deviation in output power causes 100% change in nominal frequency. Okay, सी, ऑप्शन तो लिखने दो, लेट मी राइट द ऑप्शंस, एक और ऑप्शन भी हो सकता है सही। a 10 into y% deviation in nominal frequency causes a 1000 change in output power. So D is both A and B, and C is both A and C. अभी तो एक और ऑप्शन सही हो सकता है ना, इतनी जल्दी क्या? ई, यस यस यस, ई। ठीक है, ये दोनों ऑप्शन सही। ओके, क्या है कि y% चेंज इन आउटपुट ये कर देगा, 10% में उसको 10 से मल्टीप्लाई करे, तो इसलिए ये वाला ऑप्शन सही है। क्वेश्चन नंबर 18, which is a type of advanced droop control टेक्निक? फर्स्ट है ड्रूप कंट्रोल, बी है पावर लाइन सिग्नलिंग, सी है वोल्टेज लेवलिंग, डी है वर्चुअल रेजिस्टेंस बेस्ड ग्रुप कंट्रोल। ठीक है, इसका आंसर बताओ। 18 डी। ओके, कोई और? यस, ठीक है, ये जो है करेक्ट। इट इज द मोस्ट एडवांस इन सब में से। ये भी टेक्निक्स हैं बट इट इज मच मोर एडवांस। क्वेश्चन नंबर 19, which of the following standard represent the interconnection of DER? ठीक है, कौन सा स्टैंडर्ड ये बताता है? IEC 602524, बी IEEE 1547, डी IEEE 1588, सी both B and D. बी, बी, अच्छा। Yes, the correct answer here is 1547. ठीक है, क्वेश्चन नंबर 20, the major amount of electric losses takes place in primary transmission, okay, B secondary transmission, C primary and secondary distribution, D none of the above. Yes, प्राइमरी इन द, क्योंकि यहाँ पे जो है आर resistive distribution network is highly resistive, so that's why I square R losses are very much. So question number 21, which of the following regulatory authorities regulates tariff, formulates. You can write your query in a chat box. Okay, I will respond to that. Regarding subsidies. Okay, Sanchit, you can write whatever you want to ask in a chat box. A. CA. B. Ministry of Power. C. CERC and SERC. D. None. Okay, yes. Yes, Sanchit, you can ask whatever you want to ask. Any query? Okay, the correct answer is CERC. क्या होता है? This is Central Electricity Regulatory Commission and SERC is state based. So they both make the tariff and formulate the policy regarding the subsidies. Another question, 22. The following types of inverters may not be suitable for grid connected mode. ठीक है, तो फर्स्ट इज grid feeding converters, B. Grid forming converters, C. Grid supporting converters, D. None. B. Yes, it is the right. So question number 23. The main impact of series resistance. Why is grid forming converters not suitable? Actually, what happens here is this: they controls in the voltage and frequency. Okay, so that's why it is actually, I would say, a detailed topic. Okay, one line I would say you should, you know, there's a detailed explanation why the grid forming converters are not suitable for a connected mode. Okay, so I would explain it for you if somehow like this. Just a second. Why is grid not suitable in weak grid? It will be helpful, right? Actually, right now I have not correct explanation of this, but I will when I will give the PPT of this, the notes, I will write it down in the last. Okay, so you can refer to that. Okay, what I was. Yes, yes, yes. Okay, I will give the explanation of this. Okay, because today I question what question I was on. Just a second. Just a second. Yes, the main impact of series resistance in solar cell. A increases the short circuit current, increases the open open circuit voltage. C reduce the fill factor. D increase the fill factor. Okay, so give me the correct answer. C reduce the fill factor. Okay, तो fill factor क्या होता है? It is VMP divided by I, VOC divided by IS. जब सीरीज रेजिस्टेंस हम लगाते हैं, इसका मैंने डिटेल एक्सप्लेनेशन करा रखा है कि हमारा VMP क्या हो जाता है, इट डिक्रीजेस, so that's why the fill factor will gets reduced. Okay, so now next question number 22. Power extracted in a wind energy system does not depend on which of these. ठीक है, so first is swept. Okay, swept area. B is wind speed. C pitch. D turbine radius. तो किस पे जो है पावर एक्सट्रैक्टेड फ्रॉम द विंड डज नॉट डिपेंड? ए, यस, ओके, 22 डी turbine radius. Okay, anyone else? सो बेसिकली एक फॉर्मूला होता है विच इज पावर generated, or I would say extracted from the wind, is equal to 1 by 2 rho Cp AV cube. Cp क्या था? एक कांस्टेंट है जिसको हमने we have discussed about it कि कैसे निकाला जाता है. इट इज अराउंड 70% ही पावर को रिटेन करता है. ठीक है, तो हम यहाँ से क्लियरली देख सकते हैं ए क्या होता है? स्वेप्ट एरिया. तो स्वेप्ट एरिया पे डिपेंड करता है, तो ये रॉन्ग है एज पर द क्वेश्चन. वी क्या है? विंड स्पीड. दिस इज ऑल डिपेंडेड ऑन द पिच पे भी डिपेंड करता है. ओके, एंड देयर इज ओके, सो टरबाइन रेडियस पे डिपेंड नहीं करता. सो बेसिकली द टरबाइन रेडियस इज द करेक्ट आंसर. सो सरफेस एरिया डिपेंड. नो 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 नो, देखो क्या है ना इसमें कि स्वेप्ट एरिया क्या था, उसमें कितना एरिया ऑफ विंड जो है वो उस पर डिपेंड कर रही है. ठीक है, आपके नॉट ओनली फॉर ब्लेड्स. व्हाट डू मीन बाय नॉट ओनली फॉर द ब्लेड्स? रोहित, स्वेप्ट एरिया पे डिपेंड करता है. ठीक है, तो कितना एरिया उसने स्वेप करा, उसमें देयर आर वेरियस थिंग, नॉट ओनली द टरबाइन रेडियस. खाली टरबाइन रेडियस पे डिपेंड नहीं करता. इसमें पूछा है कि अगर खाली टरबाइन रेडियस पे डिपेंड के साथ कुछ और एक आ जाता वर्ड तो इट मे बी करेक्ट, बट हेयर फॉर द क्वेश्चन इज द करेक्ट आंसर विल बी टरबाइन रेडियस. ओके, एंड clearly, actually, I would say you should go towards the lecture. I think the first lecture where I have derived this formula. Okay, there I have clearly derived it. Okay, ये एक फार्मूला था जिसमें मैंने शुरुआत में एक विंड टरबाइन को लेके इसको ड्राइव करा था. ओके, तो वहां अगर तुम जाओगे आई वुड से यू विल गेट अ क्लियर आइडिया व्हाई इन दिस क्वेश्चन द करेक्ट आंसर इज द टरबाइन रेडियस. ओके, so basically I would recommend you go toward the lecture. I think that lecture was third, maybe third and fourth, where I have analyzed in detail how this formula comes up. Okay, इसमें एक साइंटिस्ट है which has given this constant CP और इसका भी derivation मैंने कराया था. ठीक है, you should go over there. Okay, if not then you can ask me. So next question. Okay, yes, yes, yes. Okay, because today I have just come up to give you a, it is an extra session. है ना, तो इसमें डिटेल एनालिसिस थोड़ा सही नहीं रहेगा. एक चीज हम जो पढ़ा चुके हैं, why we are repeating that. If you can go through that, I would say you will get an idea why I'm saying so. Maybe you haven't gone through that lecture. Okay, so that's why. बिकॉज आई थॉट कि इसमें जो है थोड़ा हमारे क्वेश्चन ज़्यादा हो जाए तो आपका थोड़ा एक अंडरस्टैंडिंग बेटर हो जाए. ठीक है, सो लेट मी. ओके, ओके, सो लेट मी राइट इट. अगर कुछ एक्सप्लेनेशन की ज़रूरत होगी तो आई विल राइट इट इन दिस नोट्स एट द एंड ऑफ दिस नोट्स. ओके, व्हेन आई अपलोड दैट, if I think so कि कुछ और explanation I would give to you like that ना, so no issues on that side. So now here is one question I would say which I am trying to solve it for you. Okay, yes, which of these are cell balancing methods. Okay, फर्स्ट है शंट रजिस्टर बेस्ड, बी एडजेसेंट सेल टू सेल, सी पैक टू पैक बेस्ड मेथड, डी ऑल ऑफ द अबव. ओके, ठीक है, हाँ सर, ओके. अब इसमें क्या है कि सेल बैलेंसिंग क्यों करी जाती है. क्या होता है, एवरी सेल इन अ बैटरी हैड अ 24D 24 23 है, 23 है. Every cell has in a battery pack is not of a same capacity. ठीक है, कुछ हायर कैपेसिटी के होते हैं ड्यू टू मैन्युफैक्चरिंग डिफेक्ट और व्हाट एवर द रीजन. तो इसीलिए क्या होता है कि अगर इनकी सेल बैलेंसिंग नहीं करी गई तो सम विल टेंड टू डिस्चार्ज फास्टर एंड सम विल टेंड टू चार्ज स्लोली. तो इट विल ओवरऑल इफेक्ट द इफिशिएंसी ऑफ द बैटरी पैक. तो ये कुछ मेथड्स हैं. You should not go into the details of it. I just gave it for your information. कि कोई अगर पूछे कि what are cell balancing methods, so these are all this. Okay, so basically I would stop it right here. So what we have studied in the whole course here, it is our I think final session. So we have studied over about smart grid. Okay, then we have studied advantages of smart grid. Okay, and their how what are their disadvantages. Basically not disadvantages, it's like those things, like it will create newer challenges. Okay, we have also studied. Then we have studied microgrid, how they are connected in a grid connected mode, in an islanded mode, whether it is non-intentional or intentional. Then we have studied AC DC system based microgrid in this lecture series. Then we have also studied about like what are the types of DERs, solar based, and how solar should operate, like it operate in MPPT mode where the maximum power generations comes up. Then we studied about wind, and we also explain how the wind generation happens by using a DFIG, which is doubly fed induction generators. Okay, so I think this is from my side. If you have any question, you can ask me. Thank you for that. Okay, thank you.